Hey gang, uh, welcome to office hours. This is astronomy class. This is going to be the little companion video that I release with the astronomy class. I'm going to try and do these every couple weeks along with the astronomy class. So feel free to in the comments, subscribe and ask your questions down below in the comments, and I will get to them when I can. This is day one astronomy, so we talked about stars. And we talked about culture, and this is actually perfect because this is what most of the beginner lesson was about. As we were talking about culture, we were talking about stories, we were talking about how those go on and get passed on. So it's actually really cool that a lot of the questions are very related to that. I'm gonna ask a couple of these questions. I will say who they're from. Yeah, so the first question here is from Autumnal Chimera. Thank you for the questions. You had a few questions. Happy to answer all of them. So question number one was, many pop culture things reference other solar systems or galaxies, but there are many more out there that are unknown to people broadly. Are any of them in particular interesting to you that you'd like to share about? That's a great question. There's a spider on my wall. He can stay there. Hi, spider. You're a friend. So, that's a great question. There are lots of galaxies. There's lots of other star systems. So if you remember from today's astronomy class, we actually our solar system is called the solar system because of Sol. The sun is named Sol. So other star systems are not solar systems. They are specific to the star that they have in their system. So planetary systems or star systems would be the more general way to say it. But anyways, not to nitpick your response, because this is a great question. Pop culture talks about a lot of different things. And I think when we think of pop culture, when we think of other planets like exoplanets, I have gripes with exoplanet research. There are benefits of it for sure, but my personal gripe with it is when we do exoplanet research, the selling point is learn more about other planets, because we can say, oh, is there another habitable planet out there for life? And that's a really good flashy thing to get funding for, and it gets eyes, but it's not really something useful. So when we actually this is a tangent and I should not go on it. I should answer your question. I think the Andromeda Galaxy is one that we hear about a lot actually in pop culture. But I don't think people understand that the Andromeda Galaxy is something that we can see with the naked eye. This is the Andromeda constellation is in the sky, and this will tie in to the next question that you asked. But the Andromeda constellation is a really massive constellation across the night sky, and we can see the Andromeda Galaxy. I think there's also star clusters that are really cool that people don't really talk about. There's sirens in the background. Please hold. Okay, cool. Sorry about that. I think it's very reasonable for people to focus on galaxies and other star systems and planetary systems. But I think things that are really cool are actually within our own solar system. There's a bunch of things that people don't know about our solar system that I love to talk about. I love talking about, why Pluto isn't considered a planet, the fact that we didn't want to consider it a planet. And there's some really cool videos and resources about how the decision was made and how we now list all the different criteria, and it's so interesting. And we there's just really cool stuff. There's really cool stuff. I think our solar system is really cool, and I think it's something that we should focus more on. There's cool stuff happening in our solar system. We don't need to look very far outside of our local area in the universe to find really cool things. But to answer the question, the Andromeda Galaxy can be seen with the naked eye, and I really love our solar system. I think we miss a lot of cool facts about the fact that Jupiter has rings. Bet you didn't know that. Saturn has visible rings, but other gas giants and other things have rings that are also just not visible with the naked eye. So that's really fun. Fave stories. Oh my gosh, yeah, this question's a great question. Like you pointed out in one of your videos so far, so many cultures use the stars to tell stories. Very true, and I just talked about it in this recent astronomy class. What are your favorites and why? There are two stories that I think of when I think of, there are actually three, but there's two that I really, really like. When I think of stories about constellations in the night sky. There is one, and I will put a link here to, I don't have enough subscribers yet to just link an actual research paper. So I'll put it down in the description instead. But there's an Aboriginal group in Australia that still uses the night sky to navigate, and they have entire rituals around what they call the Great Emu in the sky, and it's very similar to the Southern Cross or the Cygnus the Swan. There's just really, really, really cool things. The Summer Triangle is another one of those constellations, but they have a very set group of stars that they use to navigate. They still use it to navigate. They have some really incredible rituals that they do. They track the seasons and the patterns of the migration patterns of emu in the area so that they can get the emu eggs. Like it's so precise and it's so cool, and they've been doing it for hundreds, if not thousands of years. It's really incredible. That is one of my favorite stories. And there's also a really cool, I believe there's a more personal like myth and story about like, I think it's like a woman that goes and gets the eggs, and then like the emu is upset or something. Like, I don't know. I'm gonna misquote it because I don't have it in front of me, but I will put a link in the description for that, because I think it's a really cool story. My other favorite story, the other one that's really well known, is Orion the Hunter versus Taurus the Bull. Not my favorite, but it is really cool, and we can talk about the Pleiades cluster of stars, the Seven Sisters, which sits on the back of Taurus the Bull. That's something that we can talk about at a later date, because I think that's really cool. We can talk about star clusters in another class. But my favorite story is Cassiopeia, the seated queen of Ethiopia. She is the mother of Andromeda, and I, again, forget a lot of the details, but the main point of the story is that Andromeda did something to upset the gods, and she was cursed to be forever in the night sky. And Cassiopeia, the seated queen of Ethiopia and Andromeda's mother, was very upset about this. And so she cursed at the gods for doing this to her daughter. And in so doing, the gods cursed Cassiopeia to sit on her throne upside down for the rest of eternity in the night sky. And I think it's a really beautiful story of just like a mother's love for her daughter. And it's just so cool. And honestly, cursed to be upside down, but she gets to be in the night sky forever with her daughter. And I think in a way that is like a pretty good fate in the end. So I think it's she looks at her daughter, and I can at some point I'll pull up images, and maybe I'll do like a live stream or something where I can like pull up a little resource and put it right here. But yeah, really, really cool, really wonderful story. Next question is, why will the sun die? So the sun will one day eat the planet when it becomes a red giant. These are all from Autumnal Chimera, by the way. You guys are more than welcome to ask more than one question. So this is great. The sun will one day eat the planet when it becomes a red giant. Why does this happen? I vaguely understand the composition of a star, what it burns, and all these things can change its size, but not anything concrete. So you're absolutely right. The composition, all of these things. The reason our sun will turn into a red giant is because of its size. So different size stars, different mass stars, different temperature stars, all burn at different types. And this is actually something I'll go over more in depth in the more advanced version of the star class, where we will talk about the different spectral classes of stars. We'll talk about how stars evolve and what their paths are when they die. So the path of our sun will turn into a red giant, and then it will sort of collapse in on itself. It will not turn into a black hole, and this is something that we will talk about more in depth. But the short answer to your question is the size of our sun dictates what it will turn into and how it will evolve through its death. And we will get into those specifics in a more advanced class. But that's the basic answer. Speaking of the sun becoming a red giant, is there theoretically anything to be done about it? Or is our only plausible idea, quote, let's not be here when it happens, unquote? I know it's a ridiculously far way off from happening, but the sheer scale of the event has me wondering. Thank you for all of the questions, Autumnal Chimera. Can we stop the sun? As of right now, not at all. The only thing that we know, that I know for sure that we can do, is we can accelerate it. That's the only way we can affect it right now. Adding more mass to the sun will actually speed up the process. It will cause more mass and therefore quicker fusion, quicker burning of fuel, which is very interesting. It's very funny. It's very much like a small dogs live longer kind of thing. Small stars burn typically hotter and a lot longer. It's very interesting. There's some really cool, and we'll go over this when we talk about like white dwarves and red giants and red supergiants, and then we'll talk about the main sequence of stars. I'm saying a bunch of words right now, but it's really, really cool. It gets a little tricky to keep track of, and there's a lot of things to remember, but I think it's very fun, and there's a couple activities that I will assign when we have that class. But can we stop it? No. It's about 4 billion years away, so don't worry about it too much. It is something that we should be thinking about, because we should always be thinking about the longevity and the long-term lifespan and the things that will affect our species. But this is not something that is even like on our radar right now. This is not something that we should really be worried about. But it's a great question. And as of right now, no, we really don't know a way to stop it. We don't know a way to reverse, the sun turning into a red giant. We don't know how to do any of those things. The sun is such a big, complex system, and currently we would have no idea how to do it. I'm sure there's a theoretical way to prolong the life of the sun as it is right now, but just looking at the questions and answering off the top of my head, I don't know it. But with more time and more classes, maybe I'll find a more specific answer to that question. But thank you very much for your questions. We're going to go to the next student. Icy Tones asks, WTF is the sky, and where does it stop being the sky? I don't know if it's actually astronomy, but it just popped up. That is a great question. It absolutely is astronomy. If we think about the sky and where it starts and where it stops, these are absolutely astronomy questions, and I think it's a very fair question to ask. The short answer is that it's complicated, because it's always complicated, but the longer answer is that there are many different layers to our atmosphere, and what we know as the sky is multiple of those layers working in conjunction to make visually what we see as the sky. And technically, what we imagine as the sky, where our brains basically put a roof above us, is inaccurate, right? Like there is no one line that just exists around the earth that is like, oh yeah, this is where sky ends and where space begins. Technically, directly above us is space, right? Like there is a layer at which point we feel different effects. There's the gravity is slightly different, all of these different things. And when we think about a rocket ship or something escaping our atmosphere, there is an escape velocity. So there are different things that will delineate where that boundary is, but it's not necessarily set in stone. And we have low Earth orbit satellites, and we have upper Earth orbit different objects and things. So like it's complicated, and I can. Again, I'll put a link in the description to just like the layers of the atmosphere. And I'm off the top of my head, I am not an atmospheric scientist, so I do not remember all of the different layers of our atmosphere. I am much better at remembering the layers of our sun. You know, there's the photosphere, there's the ionosphere, there's the convection zone. Like I know the different layers of the sun more than I know the layers in the Earth's atmosphere. But I know there's the ozone layer. I know there's the nope, I'm trying to recall it off the top of my head. I'll look it up at some point, and I might put a picture if I can figure out how to do that in the video, but I'll probably just put it in the description. But yeah, to answer your question, there isn't really a sky. And a lot of times when we think of the sky, what we're thinking of is just the image of space that our brain is like, oh, all these things are like creating a flat surface. And that's just not true. So I guess the answer to your question is the sky is just space. But very, very broad conceptual things to think about, and I appreciate all the questions. This has been a nearly as long as the class itself, 17-minute 17-minute video about your questions. But I hope these office hours were helpful, and feel free to subscribe. And again, hey, thanks for watching. Welcome to astronomy class. I hope to see you next time. Bye now. Bye, everyone.